Hello, everyone, and thank you for joining us for the Mastering Macroseismics and Geomechanics third webinar in the series. I am going to now turn you over to John Wei for your session. Thank you.
Thank you, Judy. Hello, everyone. Welcome to the third webinar of this webinar series. My name is Jun Wei. My main responsibility at IMaGE is software production, development, and also provide support to internal and external client. So the third webinar will be focusing on the data processing. If you remember the first webinar, we gave an overview of microseismic data processing and geomechanics modeling techniques, and we point out the usage of these techniques in unconventional oil and gas reservoir development, such as stimulation, completion design, well plan, and reservoir management. So in the following webinars of this webinar series, we'll be elaborate on the specific techniques and go through the entire workflow of data processing and geomechanical modelings. The previous webinar was focusing on the survey design, so I shared with you a few tips that you may use to maximize the coverage and also minimize the uncertainties. It's a very good exercise, actually, for you to understand your acquisition footprints before you start acquiring the data. So if you missed any of the previous webinars, you can visit our webpage, and there's a link to the recordings of this webinar. This webinar will be focusing on the data processing part, that including a project setup, and then run a detector through the data streams and look for triggers. You group the triggers into different type, and then you run a processing, either auto processing or manual processing, and you pick the waveform and you get the catalog of the microseismic data. And the interpretation part that after this step actually relies heavily on the quality of the data processing results. So that makes this step a critical part in the entire workflow, and we dedicated 2 webinars to this tasks. This webinar will be focused on the fundamental part, and we have a follow-up webinar to talk about how to do the quality control and if there's any problems that you can diagnose from a processing results, if there are, and how we can fix them. So this webinar will be more focusing on the fundamental part of microseismic data setting. And there are 2 steps that we usually do when we start approaching raw data. One is data detection or data harvesting, and next one is data processing. The fundamental information that we go after are the time and the space. So basically, it's the microseismic catalog that we can get from the raw data. So here, just going to give you a quick overview of this presentation. I'll first give you go over some basic concepts to give a big picture of microseismic data processing. So the message is, what are we supposed to do in microseismic data processing? What are we, which direction we're heading? What's the purpose of doing that? Then I'll show you how to set up a project, how we do that internally, the geometry, the coordinate of everything, the well path, the wellhead information, the well object, such as the perforation shots or the plug and sleeve locations has to be in the right positions, and the geoform orientation has to be oriented in the right location. So the expected output from this step would be something like this. It's a 3D picture, and we have our boreholes, sonic lock, treatment well, perforation shots, either you planned or it really happened from the field. If you have stream shots, it should also be included in the picture. And more importantly, it should be verified from the client. And after that, we can start to touch the raw data. And we run data detectors, and there are multiple types of data detectors that go through your continuous data streams, and we're looking for triggers. For those ones that you know the time and location, so you can group them as shots, and we use that to calibrate the velocity and also orient the geoforms. The ones that is no noise, no signals in it, it could be categorized as noise, and you can use that to calibrate your network performance. So if you remember the previous webinar, your noise is dynamic, and you can use that information to calibrate your sensitivity. The microseismic events are the major players here. The first loop is usually go through automatic processing. So you either using the time inverse method or a source scanning method, a migration type of location method, and then you can also follow up by a manual check. You can either check all of them or you just check a part of that depending on your time budget. So if you do decide to relocate some of the events, you may either need to repeat the travel time or reprocess the waveform and then get the locations. What we do usually after location is we also have some other information that automatically calculated at the same time, such as the source parameters, how big is the source radius, the stress drop, moment tensor, how the rock breaks, and those source parameter informations. And keep in mind that there are errors in the entire process. There will be errors in the velocity model, and there will be errors in the travel time, and also be errors in the geoform orientations. And more interestingly is there are errors actually in the project setup. Although you got all the information verified from the client, but there may be something that even the client are not aware of in the first place. For example, the geoform has been moved, but it's not well documented. So it's rare, but it does happen. So you have to keep that in mind when you're doing the data processing. So quality control is a very important step in this processing workflow. So this will be your expected output from this data processing step. You have dots in the box, but we don't end here. The next step is to do some quality control, reassess, reevaluate your processing qualities and see if there's some biases, uncertainties that in your processing results. And after that, you can hand that over to the interpretation. So our next webinars will be focusing on how to do the quality control and reprocessings. And after that, I'll draw some conclusions for this presentation.